Now here we have n binary strings each of length m. So in this we can swap two positions of L of I if the same two positions are being set, or if it's being 1 in the next string, that is L of I plus 1. We need to count the number of different possible strings that are possible for L1 after doing any possible number of moves. So this is what the problem states. Now this is a very good problem in my opinion. So for this problem, the first observation is that whenever we have some column that has only one number of ones or zero number of ones, then we cannot even manipulate the previous string, right? So the first point is that we should at least have two number of ones in a particular string so that we can manipulate the previous string. First point of ideation is that, so if a particular string doesn't contain at least two number of ones, then there's no point in dealing with it, because if I want to make some changes, then those two indices should be having ones in it, right? So at least we have to have two number of ones. Now let's just observe the places that has one in the last string, right? So this has one. There is a second index, fourth index, and fifth index have ones, right? So I can swap between the second, four, and then five. So second index has a one, so I can swap this one with the fourth index, and this particular element can also be swapped with the fifth index. So that I'll be getting these type of cases. So if I swap the second one with the fourth index, then I'll be getting 1 0 1 1 0. And if I swap it with the last index, then I'll be getting 1 0 1 0 1. So these are the different cases that we could get. Right, now you notice the first one and then the third one is fixed. It is fixed because it has zeros in the very next string. So we have 1 0 0 and we have 1 1 1. So I have just bifurcated all the elements and I have grouped them together so that we can visualize it very easily. So what if even this place is 0? That is, even if this place was 0, then we could not have done any number of operations. Right? So we can only do operations if one of the elements above this one is 1. So if one of the elements in the current string is 1, so if one of the elements that are above this 1 is 1, then I can make all these zeros to ones. So the basic case will look something like this, right? So if there is this pair of 1 and then below 1, then I can turn all the zeros that are below 1 to 1 1 1, right? So if you have something like this, if I have a 0 over here and if I have a 0 over here, then this 0 will not be affected in any case because it doesn't have a 1 over here. So if I can spot 1 in the current string and then 1 in the very next string, then I can make all the elements which has zeros in the place of ones to ones. So at first I'll be deriving three things. There is ones which has a 1 that is below it, and then the number of zeros in the current level which has a 1 below it, and then the number of ones which has a 0 below it, right? So in this case, if you try to see the number of ones which has a 1 below it is nothing but it's just 1. Now the number of zeros which have a 1 below it is 2, and then the number of ones which have a 0 below it is just 0. Now in this case, if you just see the total number of ones is nothing but it's 1 of 1 plus 1 of 0. So in this case it's just 1. So let's just go to the ideation 1. At least we want two number of ones so that we can manipulate the previous string. So in this case, it's not even possible to manipulate the previous string. Let's say when I have another 1 over here which has a 0 below it. Now in this case, this would have become 1 and I'll be getting two number of elements. There is two number of ones. Now in this case I can manipulate the previous string, right? So that I'll be converting this particular string into 1 1 0. That is, I'll be converting all the 0 1 pairs to 1 1s. That's how it is. So let's come to the initial example which we took. So this is the initial example that we have. Here if we calculate these values for the second string, then what will we get? So the number of ones with a 1 1 pair will be, so let me just say 1 1. So 1 1 pair will be it's 1, and the number of ones, zeros, is that it has 1 0 pair. It's 0 1 pair. There is 0 and then 1. So 0 1 pair is nothing but 0 1 over here, and then it's 0 1. So there are two number of 0 1s, and then we also want the number of ones that are involved in 1 0 pairs. There is I cannot fix. There is all these ones are fixed just because they are followed by a 0, but they'll be contributing to the number of ones. So that's what matters, right? So it's just 1 over here. So the total number of ones will be 2 in total. Right. So the case that we will be having is, if the total number of values, the total number of ones is less than or equals to 1, then we'll be continuing to the next index or to the next string. Right. Also, we just want at least one number of 1 pairs. Otherwise, we cannot even manipulate it. Right. So it will be greater than 1. So if it's equal to 0, then we should be continuing to the next index. If it doesn't satisfy any of these conditions, then some modification is possible. So in that case, all the ones, there is all the 0 1 pairs will be converted into 1 1 pairs. I'll be running a loop. If the I plus 1 string has 1 in its place, then I'll be making the current string to have 1. So how to calculate the answer for the first string, because that's what we care about. So in this case, if you see, so as we have 1 1 pair, so all the elements, there is all the 0 1 pairs will be converted to 1 1s. So it will be having the second string which is filled with 5 number of ones. That is, at some point in time, all the indices can have the value as 1 1. So all the elements can be manipulated. Now, if you look out for the first string, you'll be just looking at the second string. So we can manipulate only those places which have ones in it, right? So we'll be going to those places. There is ones in the second string, and then we'll be trying to calculate the number of ones and the number of zeros in the corresponding indices of the first string. That is, I want to calculate the number of zeros and the number of ones in the first string, which has zeros in the second string. And there is nothing but it's the 1 1 1 pair and then 0 0 1 pair, because it should be having 1 in the second string and then 1 and 0 in the first string, right? So even for the first string, I'll be calculating this 0 1 1 and then 1 1 1 and then 0 0 1. So if I have calculated this thing, then the total number of elements that could be manipulated is nothing but it's 0 1 1 plus 1 1 1 plus 0 0 1. So if you're not following me from the first, this 0 1 1 is this 1 1 1 is nothing but I'm trying to calculate the number of ones such that it's 1 in the first place, that's in the current string, and 1 in the second string. And this 0 0 1 is nothing but I'm trying to calculate the number of zeros that are present in the current string followed by 1 in the second string. So these are the total number of elements which can be manipulated in the first string, and I want to calculate the total number of ways in which it can be done. So if we have total number of values, let's say it is tot, so that there is no confusion, then I can arrange these values with tot factorial number of ways. But among these values, 1 1 factorials are equal to each other, and then 0 1 elements are similar to each other. So if you can write it in a simpler manner, then it will be nothing but it's tot c 1 1 1 for the first elements. That is, it will be the different number of ways in which we can arrange, or the different patterns which we could get for the first string. For calculating the NCR formula, we'll be using the Fermat's little theorem. Now let's discuss how to implement the code for this problem. Right. So at first, I'll be just checking the inputs for the strings. Right. Now the basic funda here is that, so I'll be going through all the strings. I'm just calculating the pairs of 1 and 1. That is, in the current string there should be 1 1, and then in the very next string there should also be 1 1. Right. So I'll be taking three things into account. There is 1 1 pair, 0 1 pair, and then 1 0 pair. Right. Now, if at all this 1 1 pair is greater than 1, and then the total number of ones is greater than 2, then I'll be making all the 0 1 pairs to 1 1s. So the basic funda is that I just need to maximize the number of ones at the current level. So for that, I'll be changing the values of zeros to ones. So when can I change that? I should be finding at least 1 1 pair, and then the total number of ones should be greater than 2. That's what I'm doing over here. I'm just calculating 1 1 0 1 and then 1 0 pairs. So if at all this total number of ones is lesser than 1, and then the number of ones is just 0, then I'll be continuing. So if this condition is not satisfied, then it means that I have more than two number of total number of ones, and then we have at least one number of 1 pairs. So in that case, I'll be converting all these zeros to ones. That is, then wherever I find a 1 in the second string, that is the next string, the I plus 1th string, I'll be changing those places to ones in the ith string. It is I'll be basically converting 0 1 pairs to 1 pair. So that the number of ones is maximized. Now to calculate the answer for the first string, I just need to look at the second string, right? So I'll be just doing the same thing, and whenever I is equal to 0, I'll be assigning the values of 1 1 1 and then 0 1 to local variables 0 1 z, right? So the total number of places that are covered is 0 plus z. That is, there are these many ones in the second string. We have some number of places which can be manipulated in the second string. That is, second string has some number of ones. Right? So we'll be calculating sum factorial divided by 0 factorial divided by z factorial as we discussed over here. Right? So how to calculate this? So this is basically nothing but it will be sum c 0. So for this I'll be using Fermat's little theorem. So we'll be calculating the factorial in the first place. So it's factorial of n into inverse factorial of factorial r and then factorial of n minus r. Right? So I'll be pre-computing the factorials along with the mods. So this is how we can solve this problem. So that's all about it for today. If you have any further queries or doubts, you may reach out to me in the comment section, or you may reach out to me in the social handles. And if you like this video, consider giving it a thumbs up and do subscribe to the channel for getting the further notifications of the videos. And with that being said, it's me from the signing off, and goodbye. Keep coding.